Alright, ladies and gentlemen, welcome to today's video. So this video is not really doing like a new lesson. Really, you should have all the tools you need to answer these questions, but I know some people like having some examples worked out so you can kind of see them and you can kind of follow along. And so yeah, our examples we're going to go over is not in the first section, but in the second section. This is about a game called, I'm going to call it ERS, which stands for Egyptian Rat Screw, but sometimes people don't like that kind of naming for things. Anyway. It's just like the above game. So you have a standard deck of cards, you split it among the people there, and you'll turn over cards, and as soon as someone lays a face card, the next person has a certain number of cards they need to flip over to get another face card. If they fail to get a face card, then the person who laid the last face card gets the stack. And so, which face card's laid tells you how many cards the next one, how many chances the next person gets. If someone lays an ace, the next person gets 4 cards. They get to flip over 4 cards, and then as soon as they get a face card, they're fine, and the next person has to flip over a certain number of cards. The jack is the most powerful one, because the next person only gets 1 shot to flip over a card, and if it's not a face card, they lose. If it is a face card, which is kind of low, they don't lose. They get to keep going. Anyway, so that's actually our first question. George lays a jack, and what's the probability that Kelly lays a face card next? So that's the probability of a face card given someone has already laid a jack. Well, there are 4 face cards in this case. In each of the suits, there's 4 suits, so there's 16 face cards. But George already laid a jack, so there's 15 face cards. And normally there's 52 cards in the deck, but when you lay a jack already, that brings it down. So now there's only 51 cards available. And so yeah, it's going to be there's 15 of the remaining 51 cards that are face card that Kelly could possibly lay next. And that's a probability. You can get a decimal approximation for that. Oh, actually, it reduces a little bit. You get 5 over 17. And that does come out to be about 0.29411. It keeps going. So looking at 29%, a little bit over 29%, which is not terrible odds, but it's kind of nerve-wracking when you only have 1 shot and that stack's really big. Anyway, next example, George laid a queen. And so what's the probability that Kelly lays a face card on the second card, but not the first? Okay, so we're going to need the probability of getting a not face card, which I'm going to call F complement, given there's a queen laid. And then we're going to have to times that by the probability of getting a face card, given there was already a queen and a face card complement. Let's just kind of break this down one at a time. The first one, we got probability of not a face card given queen. Well, we already talked about probability of getting a face card. There's 51 cards if George already laid a queen. There's 51 cards, and there's 15 that are face cards, which means you need to get the part that's not a face card. So you just go ahead and take 51 and subtract off the 15. You're looking at 36 non-face cards. And then the next fraction you get, we took out another card, so there's 50 cards left, and we want the next one to be a face card. There's still those same 15 face cards left if you've laid a queen already. And so this is your probability. You're going to times these together. It might reduce a little bit. Give me a sec. You should go ahead and try it out in your calculator and see if you can get it simplified and get the same thing as me. Alright, it's looking like I got 18 out of 85, which is about 0.21176, So you're looking at a little bit over 21% chance of that happening. Keep in mind that this is only on the second card. This is the probability of getting a face card on the first time, and this is the probability of you getting it on exactly the second time, but not the first time. And so on a queen, it's not exactly these added here, but yeah, there you go. So the next one, 9 here, George is laying a king. What's the probability that Kelly's a face card on the third time and not the first 2? Well, this is going to be really similar to this problem, except you're going to have another fraction in the middle where you don't get a face card again. And I want you to see if you can write out your the fractions you're going to multiply together to get this probability. Go ahead and write them down. Pause the video. I'll have you check in a sec. Alright, it should be looking like this, right? The first one, we want not a face card, so there's 36 non-face cards out of the 51 cards possible. And then the next one, we also not a face card. There's 35 of those left out of the 50 remaining cards. And then the next one, there's 15 unused face cards, and there's 49 cards left in the deck. And so that's our last probability there. So you're going to multiply these together. You're going to get some fraction thing, which is not going to be really kind, at least I don't think it is. But yeah, go ahead and write it down, put it in a calculator, and see what you get. Alright, you're looking at 18 over 119. Which comes out to be about 0.15126. It keeps going on forever. So yeah, 15% chance that you'll get it on the third card. But remember, you can get it on the first card, it's about 5/17. You can get it on the second card and not the first card at 21, and then you got this. So these are the probability of getting a face card when in 3 shots is pretty good, because you're kind of adding these probabilities up, which comes out to be pretty high. Number 10. Players in ERS can also win this deck if you slap it first when 2 cards of the same number are laid in a row. What's the probability that any 2 cards in a row are the same number? Well, it's going to be the probability of just laying any old card times the probability of laying the same card, given whatever the first card was. What's the probability of laying a card? Well, there's 52 cards and there's 52 of them. I know, really, really profound there. Basically, pick a card in the deck, and then you're going to times by the probability of getting that same card. At least, the same number. So there's 4 of each number in the deck, right? It's 4 kings, 4 aces, 4 tens. And if you lay one of them, there's 3 left. And if you've already laid a card, there's only 51 cards left. So you're looking like this. 52 over 52 is just 1, which means we're left with 3 out of 51, which is actually, that simplifies pretty nicely if I remember correctly, because they're both divisible by 3. I just don't know what 51 divided by 3 is. 17. Okay, so I get 1 over 17 chance that 2 cards in a row are the same number. Right, this is assuming you haven't laid any other cards yet, but yeah. You got 1/17, which is about 0.05. I'm running out of room here. What is that? 0.058882. So you're getting almost 6% chance that 2 cards in a row are the same number. And then we got our last one. 11. Slapping in our game here doesn't end there. You can also win if you slap a sandwich, where 2 cards of the same number are laid, but a different number of cards between them. So it's a probability that any 3 cards form a sandwich. Well, that's going to be using the probability of laying a card, and then the probability of laying a different card, diff card, given first card, and then you're going to times by the probability that you're laying the same card, given these things. Sorry, I'm trying to use the notation, but it's kind of hard when I'm not using variables to describe things. Anyway, so yeah, first part, you're going to have the probability of laying any old card. Now, well, that's 52 out of 52. 52 cards, and you're going to lay one of any of them. And then we want our next card. There's only 51 cards left, and we want it to be a different card, as in not that same number. There's 3 more that are the same number, and so we're going to be taking that 3 away from the 51, and that'll give you 48 cards left that are not that same number. And then the next one, there's 3 cards that are the same number as the first, whatever that was, and there's 50 cards left in the deck. And so you're looking at this level of multiplication here. This comes out to be 1, so you don't have to worry about writing that down, or at least putting it in a calculator. Doesn't do anything. And yeah, go ahead and simplify this fraction. So it's looking like 24 out of 425 chance which is about 0.056 or 7, da, 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 da. So a little bit over 5. I guess not. It's over 5, close to 6% chance there. And so, yeah, the probability of getting a sandwich, getting a sandwich is a little bit under 6. Probably just getting 2 in a row is a little bit under 6. And so, there's a really good chance as you play this game that there's a lot of slapping going on, which is part of the appeal of the game. So there you go, some worked examples. Hopefully talking aloud kind of helped you see this process of getting these probabilities. Hopefully that helps you. Good luck.